Welcome back, students. In the previous lecture, we discussed about the metal forming process, introduction to metal forming process. So we'll further discuss about this in this lecture video. So major part in this metal forming process is there is a concept called as grains. So grains are nothing but it is a cluster of atoms. So if you take any material, metal, for example, if you take steel and look in the microscope, you will not see individual atoms. If you take an electron microscope, you will not be seeing individual atoms directly. Atoms will not be available in individual nature. It will be in the form of cluster. They will join with one another and form clusters in the form of spherical globules. So those are called as grains. So you have studied in your physics about the cubic nature, face-centered cubic, FCC, BCC. So like that, you would have studied those crystal structures. So there, what happens is that from that you can understand that atoms will be available in clusters. So those cluster of atoms are called as grains. If you look at the part which is manufactured using casting process under the microscope, the grains will be larger in structure. So I'll show the diagram in the next video. They will be larger in nature. It is similar to your gravel. If large gravels are placed in a container and another container is having small gravels, and if you apply load, what happens? The container having large gravels will compress. But if you have small gravels in a container and compress it, it will not get compressed as much as the container having large gravels, because the gap is minimum in those smaller gravels, which increases its strength. Same property can be visualized in metals also. If there are larger grains in a metal, it indicates that it does not have as much strength as compared to a metal which is having smaller grains. So a part which is manufactured from casting will always have larger grains. So in order to improve the strength, what you have to do is you have to make the grains into smaller ones. So how it can be done is there is a concept called as recrystallization temperature. So it's a temperature at which the grains are dissolved. So at that particular temperature, what happens is that the grains will get dissolved and new grains will be formed. So as I said about the working process, working out increases your muscle. Similarly, when you apply load at that recrystallization temperature to the metal, what happens is that the strength of the metal increases. In other words, what happens is that the larger grains during the recrystallization temperature, they get dissolved and smaller grains will be formed. Because of the working process, what happens? Smaller grains are formed. So temperature at which new grains are formed, that process is called as recrystallization temperature. So that temperature varies from metal to metal. For steel, if you take recrystallization temperature is about 715 degrees Celsius. It is almost half that of the melting point. So melting point of steel is 1400 degrees Celsius approximately. So recrystallization temperature is 715 degrees Celsius. So at that particular temperature, if we heat the metal to that temperature, the grain starts to dissolve. And because of the working, when you apply some load on the metal at that temperature, what happens is that new grains will be formed. This process can be witnessed in the formation of blades, arval, in your roadside factories. What they do is they heat the metal to a red hot temperature and then they apply load on the metal. What happens there is this concept. The grains will be realigned, dissolved, and new grains will be formed. So that gives the high strength to the knife. That's a process by which the knife making process is done. Why they are heating the steel to that temperature is for this particular application only. One thing is steel gets softer when you heat it. The major reason why you are heating the steel is because of making the new smaller grains. So when smaller grains are formed in the metal, automatically its strength increases. So when smaller grains are there, then you can see an increase in the strength, increase in the bending strength, torsional strength, so on. And similarly, the fatigue strength of the metal also increases. So that's the reason we are heating the metal. So if you heat the metal to the recrystallization temperature and work the metal, then that process can be called as hot working process. So that's a major difference between the hot working and cold working process. So I'll discuss it in depth in the next lecture video. So today we discuss an important concept called as recrystallization temperature. So it's a temperature at which already existing larger grains are dissolved and new smaller grains are formed. Thank you, students. We'll see you in the next lecture video.